This is 237. We're going to take a look at quadratic type equations, otherwise known as factoring by substitution. And so we're going to factor and solve quadratic equations with substitution. Now sometimes we're given a polynomial and it looks similar to a quadratic equation. We call that a quadratic type. Now it's not always obvious that it looks like a quadratic equation, but what ends up happening is we're able to substitute a number or a value, usually a variable because it's much easier with variables, but we substitute a variable to represent it as a quadratic equation. And so let me show you what I mean. So I have x to the fourth plus 5x squared plus 6 equals 0. Right now it's not a quadratic equation. It says x to the fourth power. But what if I said u equals x squared? Well then, if I were to rewrite this, I get 5u, and then x to the fourth is the same as x squared squared. So if x squared is u, this becomes u squared. Now by making that substitution, it's now a quadratic equation, which now means all the things that we use for quadratic equations now apply, including factoring. And so now I can do a times c. So 1 times 6, you get 6. Factors of 6 that add to 5 would be 2 and 3. And so now I can break apart factor by grouping. And so this factors into u plus 2 and u plus 3. Now we're not solving for u, we're solving for x. So once you get to this point, once you applied what you needed to apply when it comes to quadratics, now we can resubstitute our u back in. So this is actually x squared plus 2 and x squared plus 3. So now the zero product principle, I can set each of these equal to 0. And so I get x squared equals negative 2, x squared equals negative 3. If I square root, you're going to get plus or minus root 2i. And then if I square root both sides, you're going to get x equals plus or minus root 3i. And those are going to be the solutions. So what we need to do is we need to figure out what we substitute u for. In this case it was x squared. The hint is it's always the value next to the b generally. Okay, so it's a good hint as to what I can substitute. And then once you do that, you solve for the variable. Once you've solved, in this case I was able to do the factoring for the zero product principle, you can resubstitute the value back in, and then you just finish solving. So let's look at another one. So I have x minus 3 squared minus 2 times x minus 3 equals 0. So I could say u equals x minus 3. Remember, it's usually the value next to b. So this becomes u squared minus 2u minus 3 equals 0. Well, this factors a times c, factors that add to b. That'll be negative 3 and positive 1. Now, I'm just going to kind of skip ahead a little bit. Now I can substitute back in, or I can just solve for u right now. Here's another way of going about it. So u equals 3, and then u equals negative 1. Now I can sub for u back in. So you can do it at a later time too if you want. And then solving for each one. Oops, add 3. And so those are your answers. Let's look at one more. So this one, I'm going to say u equals x to the fourth. So this becomes u squared minus 7u minus 18. This will factor, now that it's a quadratic equation, so this will factor into u minus 9 and u plus 2. I can now resubstitute them back in if I wanted to, because now I performed the quadratic tool to being able to solve this. So then x to the fourth equals 9. X to the fourth equals -2. Fourth root both sides. So you're going to get the fourth root of 9 plus or minus. And then you're going to get the fourth root of 2 plus or minus. And then I, because you can't have a negative inside of the root. Now, just to kind of show you this one, just setting it up, I can say u equals x to the 1/3 power. And it's kind of weird, but this is actually x to the 1/3 squared. Now remember, those two get multiplied, and that's why we get the 2/3. So then this becomes u squared minus 2u minus 8. And then eventually, if you get to the very end, right, let's say you get some sort of number, to get rid of it, you just cube both sides. But that may not necessarily be what it's there, but I'm just saying that that's how you eventually get to the 1/3 power. So what did we discuss today? We looked at quadratic type equations and using substitution to be able to then solve a quadratic equation. Now, in your own words, why is it called a quadratic type equation? It's called a quadratic type equation because it originally isn't quadratic, but with a little bit of substitution, I can make it look quadratic. This does conclude our lesson. If you have any other questions, please leave them in the comments.